Hello, here we go. Part 3 of special power supplies. Now we're going to talk about solar power and wind power. I'll move through these pretty quickly because we've talked about solar generation and wind generation before. Obviously any new information we will talk about in a little bit more depth, but stuff we've heard before. I'm not going to waste your time or mine by spending ridiculous amounts of time on it. So, solar energy technologies harness the sun's rays to create energy. We know about that. Every year the sun produces approximately 1,366 watts of power per square metre of the Earth's surface. Well, that is a confusing and somewhat ridiculous statement. Watts of power, watts are a measurement of power generation at any instant. It's not bound by time. It's saying that it produces 1,366 watts of power in a year. Doesn't make any sense to me. But anyway, and it seems pretty low anyway, like 1.3 kilowatts per square metre. Imagine how many meters of power, or meters of solar power panels you'd need to generate any useful power. Anyway, let's ignore that. Solar energy is a fast-growing way to harness power, and some experts think it will contribute 50% of the total world's energy use by 2050. Would not surprise me. New Zealand receives about 2,000 hours of bright sunshine every year. Obviously that's different in different places, but this is enough sunlight to generate approximately 4 kilowatts per square metre every day. Well, okay, so if we can get 4 kilowatts per square metre every single day, then how come we only get 1,366 watts per square metre in a whole year? In the sentence above that, I don't know. 4 kilowatts per square metre each day sounds a bit more likely. There are 2 types of solar energy devices available today: solar thermal converters and solar photovoltaic converters. What does that mean? A solar thermal converter are the oldest systems collecting energy from the sun. So when we talk about solar panels, we're generally thinking of solar voltaic converters, but a solar thermal converter is a far more rudimentary or more simple device. Thermal converter uses dark coloured panels and sometimes reflective panels placed on areas such as rooftops to absorb the heat from the sun. The panels collect heat, which in turn heats fluid such as oil or water. As this heated fluid travels through the panel, it absorbs the sun's heat energy and produces hot liquid or even steam. If steam is produced, the steam turns a turbine, creating rotational energy that is converted into electricity by a generator. And so a thermal converter is just the heat of the sun. It's not actually producing power, it's just getting the heat. Now, these are pretty common, right? The devices that would run water through panels on your roof to help heat the water in your house, they're common. Well, they're not common, but they've been around for a long time. We would then use the heat from the fluid to, particularly if we're able to generate steam, then we can use that to turn a turbine, and then that turbine can create power. But we don't have that very often in our homes. There is an example of that I've seen before, which I believe I've mentioned to you, but if we have a look here real quick, the Ivanpah Solar Power Facility, which is in Las Vegas, or just outside Las Vegas. Drove past it a couple of years ago. That was flipping awesome. I thought it was a solar panel, like solar power generation facility, like solar panels, but it actually was just a whole bunch of mirrors. All the mirrors were pointed towards these towers. The towers have water in them. All the mirrors heat the water and therefore create steam, turns a turbine, which there is a picture of there. Make it bigger. So each of these little things here is like an individual mirror, and they're all pointing up towards this tower, and that creates a whole bunch of heat. And the heat turns the turbine, so it just generates power like a regular turbine thing, but using mirrors and using the sun's rays to heat the water, which I just think is fantastic. Coolest thing, might be the coolest thing I've ever seen in my life. If you ever go to Vegas, book a little side trip out to the Ivanpah. Yeah. Okay. All right. I can hear you from here. Maybe it's not as exciting for you as it is for me. Now, solar energy, solar photovoltaic converters. A solar PV converter converts sunlight energy into electricity. This is the solar panels that we're used to when we think about solar power. A typical PV panel consists of 2 or more thin layers of semiconducting material, which is commonly silicon. PV cells are connected together and encapsulated to form a module or panel. When light strikes the silicon, it produces electrons that are conducted away by a metallic grid as direct current, DC. This is then sent through an inverter and converted into alternating current electricity for use in the home or at school, or wherever else we might be using it. So if you've got solar panels, you'll also have some sort of solar controller, which is part of that is an inverter, which is turning that DC power into AC and then feeding it into your normal power supply. So in that respect, your DC or your solar panel then is kind of acting like a solar, like a light powered battery, kind of. Yeah. When light shines on it, it creates some power. We put that power, invert it into AC and put it into our houses. Neat. Infinitely renewable, right? Because the sun is there. It's not going anywhere. I hope it doesn't. I mean, yeah. Theoretically, infinitely renewable. There's certainly no other power source on Earth that is more renewable than the sun. So there are our basic components. We have a solar panel that's up on the roof. We need to point that ideally at the sun, whichever direction the sun is coming from. That's where we want it. Regulator. So the regulator will regulate that voltage. Obviously we need to regulate the voltage. Then the voltage is going to change depending on sun conditions, all that kind of stuff. Go to a battery. Some systems don't have a battery. A battery is good because the battery, we can charge it, so we can get a lot of power during the day, charge our battery, use that power at night if we needed to. Whereas if we just went straight off the solar panels, then we only have power when the sun is shining. And then we go through our inverter and out to our AC loads. So grid connected residential solar panel systems or solar power systems. A grid connected solar power system is directly connected to the home and to the grid. So in this case we don't have batteries. The grid connected system allows the homeowner to get power either from the home electric solar system or the power grid. Switching between the residential system and the grid is seamless. So there'll be some sort of automatic thing in there that's switching. If we've got power coming from our solar panel, then we use that power first. If we don't have any, then we come from the grid. The prime advantage of this type of system is the ability to balance the system production and home power requirements. When a grid connected system is producing more power than the home is consuming, the excess can be sold back to the electricity retailer in a practice known as net metering. When the system is not producing sufficient power, the home can draw power from the grid. Grid connected systems are the lowest cost type of residential solar electric system due to having fewer required components. So that's pretty cool, right? So when we're producing more power than we need, so at bright daylight, especially if we're not home during the day, then we sell that power back to the grid. Then at night, I use power from the grid. So like one way power's going out, and let's say my electric meter turns backwards, and then when power's coming in, it turns in the normal direction. If I generate more power than I use, then my electricity costs me nothing. In fact, theoretically, the power company might even pay me. So I don't need the batteries then. Essentially the power grid is operating then as my energy storage, right? Because I pump it out into the grid and sell it when I don't need it, and then I bring it back when I do need it. So it's not really acting as power storage, but from my point of view it is, because I can store up the power that I've used by selling it to the grid and then get it back by buying it back from the grid. Pretty neat, huh? I think these are becoming less common actually. Let's just talk about that a little bit. I think they're becoming a little bit less common because I think the power companies are not that fond of buying that power from you. I know that certainly they'll pay you less per kilowatt hour for power that you generate than that it costs you to buy power from them, which is a bit of a rip-off. I guess they gotta make money somehow, right? And you need some pretty complicated stuff, right? Because you can't just send power back to the grid. It's got to be in the right phase, you know. It has to be in phase, otherwise you're going to get short circuits when you turn it on. So you're going to have a controller in there that's doing some clever gizmos to make sure that the power that's going out is in phase with the power on the grid. And, you know, then you start to undercut the generating capacity. Like, what if everybody in New Zealand was doing this and pumping power back into the grid? Then it's like we have all these power stations that become useless. So the power companies, I think, are a bit funny about buying that power off you these days, but they're just going to have to deal with it. And the more we put solar power systems onto our own houses, and not even just houses, like commercial buildings and stuff being built with solar power systems, then the power companies and the large generating facilities that they have become more and more redundant, right? It's a cool way of decentralizing the power generation and then kind of decoupling ourselves as individuals from central power networks, I suppose. And when I say power in that context, when I say central power networks, I'm not talking about electrical power. I'm talking about the power structure of our society. You know, that we are beholden to certain organisations, government, big private companies to get the things that we need. Like if we don't need big power companies to supply our power, then we hang on to a little bit more of our own individual power, not electric power, our power as people. Okay, veering off into some strange political ideologies, so let's move on. Alright, grid connected residential solar power system with battery backup. A grid connected solar power system is also connected to the national power grid and adds battery backup to the system. The addition of a battery backup enables the system to balance production and demand and protects against power outages. Solar electric system production depends on the available sunlight. When sunlight is abundant, so middle of the day, production can exceed demand, so we produce more than we are using. When the production exceeds demand, the excess power can charge the batteries, which store the electricity. When the system is producing less electricity than demanded by the home, so like at night time when I get home and I need to cook and people are taking showers and stuff, so we need more power, but it might be dark, so we're not getting power from the solar panels. Then the batteries can make up the shortfall. Grid connected systems are also connected to the power grid. This enables the homeowners to draw from the grid in periods of excess demand and to sell power to the grid when there's excess production. While grid connected systems offer more flexibility, they are not without disadvantages. Charging and discharging batteries reduces the overall efficiency of the system, and these systems are more complex to design and install and therefore more expensive. Yeah, I don't know about grid connected battery systems. I don't know if I've come across one. It tends to be battery systems or grid connected systems. Off-grid system. An off-grid residential system is completely disconnected from the national power grid. Without a connection to the grid, batteries are essential to balance periods of excess production and excess demand. Yeah, that makes sense, right? Because that means if it's not sunny and I have no batteries, I have no power. If I'm going to be completely off the grid, I must have some way of storing the power that I'm generating. To protect against shortfalls of power when the solar system is underproducing due to weather conditions and the batteries are discharged, an electric generator such as a small wind turbine or backup generator is usually added to the system. The generator is used as a power source during periods of prolonged excess production or unusual demand. I've never come across a house that's completely off-grid. I do remember one a long time ago that had a wind turbine, and we went out there when I was an apprentice to have a look at the batteries because they needed to be tested, and just made sure that they were operating efficiently every 6 months or so. So we did a load test on the battery cells. I don't think that house was completely off-grid, but that would have been the closest that I've seen. It's probably going to become more common, right? As these sorts of technologies become cheaper and more available, more and more lunatics, independently minded people like myself may attempt to, or find it desirable to, disconnect themselves from the grid. And as I said, if the equipment is more available and cheaper, that's going to give them more opportunities to do so. So in your lifetime as electricians, you are probably going to find that this becomes a little bit more common. Wind generation. What is wind generation? Well, we know. Wind energy is generated by harnessing the wind and is the world's fastest growing energy source. It's becoming more important for electricity companies to use wind energy as it is renewable and a free resource. Wind energy plays a useful role in energy generation in New Zealand. There are currently 7 wind farms in operation in New Zealand. Combined, these wind farms have a capacity of 170 megawatts, which will produce enough energy for about 75,000 average New Zealand households. Right. So I think it's more than that. I don't know how old this PowerPoint slideshow is, but I'm pretty sure there's more than that. Remember, we have looked at before a Wikipedia article called Power Generation in New Zealand or something like that. It actually lists every single power generating facility and how much they generate. So if you want to know more, that'll be the place to go. What I will say about this, however, is in a couple of slides ago in Solar Energy, it said that people were predicting that 50% of the world's energy is going to come from solar power and by 2050, so that's like 30 years away. If you look at the trends in New Zealand, then you would suggest that wind power is going to be our next major power source. Currently, hydropower, which is renewable as well, is our biggest power source, but I suppose there's limits on that in the sense that there's only so many rivers you can dam, and then you can only dam them so many times and all that kind of stuff, and building dams in strange locations become more expensive. It's got to have the right conditions and environment. So whereas wind power, you just stick wind turbines at the top of the hill. They appear to be, nearly all of the new power generating facilities that I know of, like in the last 10 years, are wind facilities. So they're getting bigger and bigger all of the time. And I don't know of any solar power producing facilities in New Zealand. So one would suspect then, following that trend, that if we look at what the renewable energy situation will be like in New Zealand in 30 years, then we're probably going to have a lot of wind generation, which is good, which is a good thing. We're not relying on finite resources like fossil fuels. We don't that much anyway. And then we don't rely on other countries, which I think will become more and more important as the world as we move on into the future. And by 2050, I'll be damn near dead anyway, so who cares? But a lot of you guys will be potentially in the prime of your lives, or certainly have plenty of living left to do. So it's probably quite important to you. Electricity companies harness wind energy with wind turbines. When the wind flows past them, the turbines' rotor blades, the blades turn and convert wind energy into kinetic energy. So wind energy turns into mechanical movement energy. This spins a rotor inside the generator, where the kinetic energy is converted to electrical energy. We know how power is generated by a turning rotor. That's something we've talked about a lot. Once the wind energy is converted into electricity, the electricity flows through the cables in the turbine down the turbine tower to connect with the output from other wind turbines at the wind farm before entering local electricity networks. The greater the wind speed, the more electrical energy is generated. Each wind turbine has 4 key parts: a foundation, a tower, a nacelle, and a rotor. I'm not sure if that's how you pronounce nacelle. That's the first time I've ever seen that word. What are they? Well, the foundation obviously is the bit where it all connects to. And the tower is the big tall bit. It has to be high because we want to get the wind, and obviously, and the rotors on these things can be pretty big as well. So they need to have some clearance from the ground. The nacelle is the little bit at the back there. So it's this guy, which I guess is the mechanism. That's where the gearbox and stuff generator is. And then we have a rotor, which is part of our generator. Foundation holds the turbine in place on the ground. Yeah, we know about that. Nacelle is the heart of the turbine, where the generator, gearbox, and turbine drivetrain parts are held. The generator inside the nacelle is used to convert the wind energy into kinetic energy, and then into electrical energy. The rotor. Most wind turbines have 3 blades that are attached to the rotor. Blades and wind turbines are tested thoroughly to ensure they will stand up to the most severe weather conditions. Each wind turbine has an internal computer system that monitors the direction and speed of the wind and allows it to automatically set itself to operate at a safe level. If there is any damage to the turbine, it's due to overcapacity, wind speed or strength, the turbine shuts down automatically. Now, I've seen this before. I talked to you guys about this, that the wind turbines will, you can see one running full speed and the one next to it is stopped. So obviously there's some sort of mechanical system in there that can stop the wind turbine turning, which is important. If you don't think about it, you don't think about it, but when you do, you realise it's important that you're able to stop it, otherwise these things could go crazy out of control and there's nothing we can do about it. Alright, that's enough about wind turbines. Let's talk about access codes. The third digit for your access code for this test will be a 6. Now, all 3 digits for your access code. I suppose you could stop this video and go and do something else now. Go and do the test. But I encourage you to stick around. I'll get lonely if you don't watch the rest of it. Alright, landfill generation. We've talked about landfill generation before as well. When organic waste decay in landfills, they produce biogases, the most abundant of which is methane, one of the most harmful greenhouse gases. Usually the biogas just seeps out over many years into the atmosphere. However, we can use the methane present in landfills constructively as a renewable source of energy for generating electricity. The main advantage of such a system is the using of methane gas, which is harmful to the environment. The main disadvantage of the system is that it is dependent on the rate of decomposition. Okay, so the advantage there is that methane is going to go up into the atmosphere and cause damage, and if we burn it, well, that might not sound particularly environmentally friendly, but it's actually more environmentally friendly than just letting that methane out, so burn the methane. The disadvantage there, okay, yeah, so we put waste in a landfill, and then like probably many years later we come along and go, we're going to use this to get power out, and then they kind of dig some wells and get the methane out, but it depends on what's in there and how long it's been decaying and how well we can extract it. You just kind of have to wait and let it happen. Well, I've just had an absolute blew my mind moment, which I'll come back to in a second. What have we got here? Oh, crikey. Yeah, okay, so here's a diagram of what the basics of what a landfill type system would look like. Number one there is a network of underground pipes which we would have to dig into place inside the landfill, the brown part there representing the landfill. Number two would be a collector chamber which would get the gas out, and we feed it into number 3, which is some sort of engine which is going to burn that, drives an engine, turns a generator, creates power at number 4. Very simple. So number 1 there with the gas wells, perforated pipes are driven into the landfill to collect the biogas, so they're just banging pipes into the ground to get the thing in there. The biogas treatment, water and other impurities are removed from the biogas. It's then stored, so that was number 2 in the diagram, stored when required for energy production. The turbine, yep, so that's the engine that burns it. And the generator, so that's where the turbine is going to turn the generator and produce power. We know this stuff. Right, Auckland. The Auckland power generation facilities are very similar. Greenmount has 6. Did I skip a slide? Hang on. Okay, no. Greenmount has 6 generation units and Rosedale 3. Greenmount, 5.5 megawatt capacity, began operation in June 1992, and Rosedale 6 months later, 2.7 megawatts. These are the 2 largest methane gas generation stations in the country. Okay, this is where I just had a brainstorm. I was like, boom, I just realised something. So the Greenmount facility is on Harris Road, which is literally around the corner from MIT. Well, it's around the corner from the current MIT if you're watching this. In 2021, then you'll be at the Manukau facility. But if you think of the Otara facility, Otara MIT, then the Greenmount facility is down the road. I drive past it every single day. Now, there is a giant hill in that same area. So Greenmount is the road, right? So the corner of Harris Road and Greenmount Drive. That's where that facility is. There's a giant hill there, and there's nothing there. And I've always wondered, like I can see that hill from my house, and I've always wondered what that's there for. You see, like plant driving around in there sometimes. It looks like they're doing something, but you think, why would you have that big area in the middle of a pretty densely populated residential area of Auckland, and there's nothing there? And I just realised, just when we were talking about this now, that big hill is the landfill, right? I don't know this for sure. It's just popped into my head. But I would bet money, given the location of that Greenmount site and what an old landfill looks like, as in a big man-made hill, and the fact that in that location a giant area of no stuff, especially considering it's not like a park, you can't get in there. It seems a very odd usage of land. All of those things add up to tell me that that is the landfill. So that is where the methane gas is coming from to supply that Greenmount facility. Cool. How cool is that? One day we should go and have a look. I wonder if I could plan a field trip there. Maybe we could just break in, run around on the hill, see if we can find the methane pipe network. I don't know. Remind me when we're back at class to do something. We'll go there. Something. Alright. And here is a picture, a beautiful picture of the Rosedale landfill generation plant. Doesn't look like much, does it? Okay, I guess it is what it is. That's it. That is the end of this one. I've given you the code for the quiz. That should be all you need. Any questions? Get in touch. Let me know. Otherwise, I'll see you at the next one. Thank you for your time.